Welcome back to the Galaxy Explorers YouTube channel. Today we're going to be breaking down one of the most popular and surprisingly complex experiments that we run here at our Galaxy programs, which is the baking soda and vinegar bottle rocket. You've probably seen this before on our social media or on YouTube, and it looks really simple and fun, but behind that quick launch is a full package of real-world science, including acid-base chemistry, gas pressure dynamics, Newton's laws of motion, and even some principles of rocketry and aerodynamics. So if you've ever wondered how this little reaction can launch a bottle 10, 20, or even 30 feet into the air, this is the full breakdown. Let's start with the materials. First of all, you're going to need a standard 2-liter soda bottle, which is going to be your rocket body. You'll also need some baking soda, also known as sodium bicarbonate. Next, you'll need some vinegar, which contains acetic acid, as well as a small square of paper towel. You're also going to need a cork that fits snugly into the mouth of the bottle and 3 to 4 pencils or popsicle sticks taped around the base of your bottle as a launch stand. First, let's talk about the chemical reaction. When baking soda and vinegar mix, they create an acid-base reaction. The reaction produces water, a salt called sodium acetate, and carbon dioxide gas. That carbon dioxide gas is the driving force here. Once it starts forming, it has nowhere to go because the bottle is sealed with our cork. As more and more carbon dioxide builds up in our bottle, it increases the internal pressure inside the bottle. By wrapping the baking soda in a paper towel, you can delay the reaction for just a few seconds, which is long enough to seal the bottle and flip it upside down onto your launch stand. This is where chemistry meets physics. The pressure buildup follows the ideal gas law, which is PV equals nRT. Let's break down this equation. P stands for pressure. V is volume, which is fixed by the size of our 2-liter bottle. N is the number of gas molecules in our bottle, which increases as carbon dioxide is produced. R is our gas constant, which is listed here, and finally T is our temperature. As the number of gas molecules increases, but the volume stays the same, the pressure inside the bottle rapidly rises, and eventually that pressure forces the cork out of our bottle, and when that gas begins to escape downward, it pushes the bottle in the opposite direction, which is towards the sky. This is a perfect demonstration of Newton's third law of motion. For every action, there is an equal and opposite reaction. The action is the gas shooting down and out of the bottle. The reaction is the bottle launching upward with force. This is essentially how every single rocket works. They expel mass in one direction to create some movement towards the other direction. And Newton's first law also applies here. The bottle won't move until the force from the built-up gas exceeds the inertia and friction holding it in place. And once all of that finally happens, the rocket is able to launch off. Now let's talk about some aerodynamics, how to make the rocket fly better, not just higher, but straighter. First of all, fins help stabilize the rocket by keeping the center of pressure behind the center of mass. This reduces tumbling in the air. A nose cone improves airflow and reduces drag, helping the rocket cut through the air more efficiently. And last but certainly not least, a stable launch setup using pencils or popsicle sticks keeps the rocket vertical at ignition so that the thrust is directed properly. Ultimately, you're just designing for controlled motion, which is exactly what aerospace engineers do when they plan actual launches. Now, instead of baking soda and vinegar, real rockets use liquid or solid propellants that generate hot gases and extreme pressure. But the process is ultimately similar, creating an expanding gas and directing that pressure through a nozzle and using that to lift off. Launch systems like the Falcon 9 or the SLS all operate on these same basic principles, just at a much larger scale with more fuel, more thrust, and more guidance systems. Now here's how you could try this experiment at home. First of all, fill your bottle to about 1/3 full of vinegar. Second, wrap 1 to 2 tablespoons of baking soda inside a paper towel, folding it like a packet. Now, drop that packet into the vinegar and quickly seal the bottle immediately with a cork. Then flip the bottle upside down onto your pencil stands and wait for the rocket to launch. Within a few seconds, the cork will pop and the rocket will launch once the pressure buildup inside the rocket bottle is sufficient. Now make sure you're launching this in an open space, and safety goggles are highly recommended, especially for younger scientists. Now if you're into chemistry, physics, or just aerospace engineering as a whole, this experiment is a great place to start applying what you know in a fun, real-world way. And we've done this a lot at dozens of galaxy camps, and every time the science hits harder the more you understand what's going on behind the scenes. Now in future videos we're going to keep talking about all of this aerospace engineering, rocketry, orbital mechanics, and more fun science, so make sure you stay tuned for our next video.